Tēnā koutou. Welcome to week 3 of Digital Media. Following on from last week's focus on political economy, this week we're going to be thinking about some of the key technologies and infrastructures that enable digital media to function. By studying the code, hardware and standards that are needed for digital media to exist, we find another series of social, cultural and political issues that aren't present at the levels of texts or audiences. In this first video, I'm going to be introducing digital infrastructures. The next video builds on this, looking at some of the social and ecological harms that are associated with digital hardware. Videos 3 to 5 shift the focus towards software. Video 3 defines algorithms, automation and artificial intelligence as key terms surrounding contemporary code. Video 4 looks at various ways that algorithms are associated with automating inequality, before we finish up looking at Google's PageRank algorithm as a specific example of how inequalities can result from algorithms. So, what are infrastructures? One way of defining infrastructure is the hardware, software, standards and organizations needed for technology to function. We typically only think of new technology as being technology. After a while, technologies simply recede into being the background of the world, something that we take for granted, like having a functioning plumbing system or a fridge. But plumbing and fridges were both once cutting-edge technologies that changed how people lived. It's just that they predate us, so we don't tend to think about them in that way. Indeed, we rarely acknowledge the way that all sorts of technological innovation, from screws to electricity networks to plastics, are absolutely essential to the functioning of our everyday lives and our digital media. These technologies are what we describe as infrastructures. They form the connective tissues and circulatory systems of modern life. So infrastructures are the almost invisible background that enables the visible technologies we use to function. That doesn't mean that infrastructures aren't themselves technologies. They are, but we rarely think of them in that kind of way. For example, when we think about a smartphone, we think about the device that we hold in our hands, what we identify as being the technology, not the networks of hardware, software and technical standards that are needed for the smartphone to actually work. In the case of the smartphone, we can point to networks of hardware that include undersea and underground fiber optic cables, data centers that are filled with computers and networking equipment, 4G wireless antennae, and a network of GPS satellites that orbit the planet. The software includes the firmware and operating systems on both the phone itself and every server, router and other device on the network. Applications, the specialized software that's used by Facebook, Google and other social media platforms. The content management systems that are used to build and maintain websites, apps and other digital media, and so on. Protocols and standards like Wi-Fi, the transmission communication protocol and the domain name system allow hardware and software to connect and communicate with one another. So they're absolutely essential for smartphones to actually work, and so are the organizations that maintain those standards. From an infrastructural perspective then, the smartphone itself is only a tiny piece of a vast network of things and people. Now, just because infrastructure isn't made to be visible doesn't mean that it's not important. As critical infrastructure studies scholar Susan Lee Starr explains, study an information system and neglect its standards, wires and settings, and you'll miss essential aspects of aesthetics, justice and change. While we might think that infrastructure sounds value neutral and boring, infrastructure in fact reflects social value systems. For example, the protocols that manage the World Wide Web were designed to be openly accessible because Tim Berners-Lee, the scientist who wrote them, wanted other scientists to be able to easily share data with him, not because they had to be that way. And recently that openness has been altered with the encrypted media extension specification that's part of HTML5, the latest version of the web's language. This largely came about through corporate lobbying, while being strongly opposed by open web advocates. We see from this example that protocols and standards are sites of conflict which enact different value systems. In Aotearoa, New Zealand, we tend to only notice infrastructures when they go wrong, like when you can't connect to Wi-Fi. But this isn't the case in many places around the world though, where electricity, internet connectivity and other infrastructure fails on a daily basis. Maintenance is a key term associated with infrastructure. These complex global systems require constant upkeep to continue working. Consequently, American infrastructure studies scholar Steve Jackson argues that we should take erosion, breakdown and decay rather than growth, novelty and progress as starting points for thinking about infrastructure. Ensuring that digital infrastructures keep working requires a huge amount of labour. But whose labour is this? We'll return to that question in the next video. For now though, what I want you to do is write down all of the infrastructure you can think of that's been needed for you to watch this video. Alongside the technology, try and think about some of the jobs that people have had to do to make all of this possible. We'll discuss your answers in your workshops and forums this week.